Hello guys, welcome back once again. In the previous session, we talked about OSPF. We learned what is OSPF and we also learned the configuration of the OSPF in the routers. So, and the first thing, I'm really sorry that I was not able to record any of the video in the previous week. I was a little busy preparing for the firewall. So, anyways, and one more thing I want to tell you that whatever I'm telling today in this video, that is very important for the OSPF and that is asked too much in the interviews. So just watch this carefully. Okay. So the first thing what I am going to tell you, that is the OSPF messages. Okay. So whenever we are having the two routers, right? Or in fact more the routers. So for the example, I have just taken the two routers. So whenever you configure OSPF in the router 1 as well as in the router 2, right? So let's say suppose you have configured just on the R1, not on the R2. So whenever you just configure the R1, the first and very first thing it does is just send an hello message on its multicast address, right? So the very first message, that is a hello message, and that is just to tell the neighboring router that yes, I am having this router ID. It also tells its router ID to the neighboring router, and it informs the other router that I am running OSPF. Are you also? If this router is also running OSPF, then it will respond for that one. So that's also send an reply for that one, right? So that is just a very first message, that hello message, and that is being sent to initiate the neighborship, right? The second, the packet is database description. We also call this as a DBD packets, and we sometimes you also call it a DD, but normally in the majority it is called as the DBD packets. So DBD is like database description, and whenever we have some parameters matches, and then what is happening? This router 1 is sending its routes to the neighboring router, right? So that is being done in the neighborship, not in fact the neighborship, that is the database description. Means it whatever the database it is having for the routing table, or whatever the information it is having, or its database topology information, that it will send it to the router 2, and the same thing it is done by the router 2 back to the router 1. So that is just database information sent from router 1 to router 2 or to any other router. That is the second type of message that will be is being sent on the database messages, right? What happens that sometimes it they share, R1 shares the route with R2, but still there are some of the routes missing in the routing table or in database. I should not say the routing table right now, but I just say you so that you can understand. But actually that is just database, the information of the routes. If that information of the routes is missing in, suppose this is having 5 routes, right? While the router 2 is having the 9 routes. Correct. So it's just whenever they are sharing the database to each other, it has been sent from R1 to R2 to R1 and R1 to R2. Then obviously they are having some changes. They observe that my database is less while the router 2 is having the more database. So what it does to get update of the remaining routes is sends a link state request. It generates an LSR that please send me the remaining routes. This is just extra request. First, it has shared the database, but still there are some missing. For that one, it is being the request is generated, and that is called the LSR. Another type is the acknowledgement. Whenever any of the packets transfer is happening, in the reply what is being sent, that is an acknowledgement. We always acknowledge the things whatever is being sent from one router to another router, or in fact I should say that one device to another device. So that comes in between. But actually what is happening, this, if you go to the previous one, we have requested the link state request, and then it is sending the link state update. So it is like a request, you are requesting something and you are getting the reply. So this message is link state update is a reply of this message, link state request. This is called the LSU, that is link state update. So these are the 5 messages that are being sent in the OSPF. Clear, guys? That's good. Let's move further. So I just discussed you in the beginning that whenever router 1 configures the router with the router 2, they send a hello packet, right? What are they sending in the hello packet? They are sending router ID to the router 2. So the question arises, what is this router ID, right? So for that one, let's have a look on that one. The OSPF router ID is used to provide the unique identity to the OSPF router. It's like that you are in the class and you're having some name. Your name is there in the class. So somebody calls you, okay, please stand up, Mr. Anuj. Then that guy is a stand up. So that is just like a name to the router. And that is actually an IPv4 address. And you already know that that IPv4 address is a 32-bit binary number, right? So that is being assigned to the routers. And that's also thing that router ID should not be changed after the OSPF process has been started and the OSPF neighborship has been established. It's like that whenever you have initially the router ID is something like, suppose this is 1.1.1, it has sent hello, it has got the reply, whatever the parameters matching, they are matched, and they are adjacent to each other, right? They have shared the database and something, what everything is up now, they are in the very fine state. And after that one, if you change the router ID from 1.1.1 to 2.2.2, then OSPF may not work properly and OSPF does not work, right? So that's very important part, that once the OSPF neighborship is up, you should not change the router ID in that case. And even if you change the router ID, then you have to clear that OSPF process using the command clear IP OSPF process. You have to use that command in case you want to change the router ID of the routers. So that is the very important part. But the thing is that what is this router ID and how is this being assigned? So what is this one that we have discussed? What is this that we have discussed? But the thing is that how is it being assigned? So for that one, I will prefer to go to our routers, right? So let's just jump to our lab and let's try to understand from the lab that how actually it works. Okay, so I'm just let me open the packet tracer here. I will just take a very simple 2 routers, and then I will just demonstrate you how actually the router ID configuration is being done, right? So for that one, although there are just 2 methods. The first thing is that you can assign the router ID manually. That is the very first process, that you just assign the router ID manually, right? So that's very easy way. Normally people do it, but what happens in the real scenario, or in fact if you are doing in the lab or somewhere, then you observe that you do not configure the router ID manually. So the main algorithm, or what is the backend process, if you do not configure the router ID manually, then how does it work, right? So that we should understand, and that is really very important. And most of the time it is being asked in the interviews. So you have to just uh, be very careful doing this lab. Clear, guys? So let me open my Epic Pen, and this is okay. We have opened that one. Let me close it. Fine. So let me take one router and let me take one more router. Perfect. And just I will just take a very simple topology here. I will just connect them like this one. Perfect. No configuration, nothing. They are just very new. What I am going to do, I will take one subnet here, 10 dot or 10.1.1.0/24. what I'm going to do, I'm going to assign 10.1.1.1/24 IP here and 10.1.1.2/24 IP address this side. So there are two interfaces. Clear? There's this side Z0/0 on the router 0 and the 10.1.1.2 on the router 1. So I think let's also change the name of the router as well. So that will not confuse with the IP address router 2. And this is our router 1. Perfect. Let's go to our router 1. The very first job that we have to do, that is to assign the IP address to the interface. So config t IP is enabled, and then config t and IP interface G0/0/0, and let me give the IP address here 10.1.1.1 subnet mask 255.255.255.0. No shut. Perfect. The same thing I have to do it here, and I just missed the no shutdown command. So let me do that as well, otherwise it will not come up. No shut. And the same thing I'm going to do it here. Yeah, let's do it here. That's full screen, no problem with that one. No. Enable config t. I remember the interface, that is interface G0/0/0. And IP address I have to assign 10.1.1.2. Subnet mask is 255.255.0 and no shut. And the now ports will be up most probably. Yes, they are. So let's just check the router ID. Let's just check the router ID. Not right, because till now it will not be having the router ID, right? Why it will not be having? Because we have not configured the OSPF. So first, just let's configure the OSPF. Config t router OSPF process I'm giving as 10, and let's advertise our network. What will be the network? Network is this one, 10.1.1.0 network 10.1.1.0, and then we can give the wildcard mask 255. Incomplete command, I have to also give the area 0. I'm putting on the area 0. Perfect. And let's just check that whether we have the IP protocol or not. Show IP protocols. So if you observe, you are having the OSPF protocol running with the process ID 10, OSPF 10. And if you just check it, the router ID is 10.1.1.2. We have not assigned the router ID manually, but still it has taken the router ID as 10.1.1.2. What it does actually is just automatically takes the physical IP address that you have assigned on the interface, right? What it did is just use the IP address that was assigned on the physical interface. Clear, guys? Whenever you don't assign router ID manually, it will take the physical IP address. Perfect. In fact, same thing we can do on the router 1. Clear, guys? So let's do, or in fact, configure the OSPF here as well. And let's do the same thing. Network 10.1.1.0 wildcard mask as 0.0.255 and area 0. And exit. And now we can run the same command, show IP protocols, and it will tell you the router ID. And here router ID is 10.1.1.1. Clear, guys? Right now it's clear that whenever we are having the routers and we do not configure the router ID manually. Now you might be thinking I'm talking about again and again that configured router manual. Then where to actually configure. So let me show that as well first. Configure T, you have to go router OSPF and whatever process you are running, and after that when you have to give the command router ID, and whatever the router ID you give, that will be assigned automatically. So let's give it here 1.1.1.1. As you enter it, because we have just discussed that we should not change the router ID once the neighborship has been established. And if you observe it, that you will see that it has already been state as full. Loading is done. It means that we are having the adjacency with the neighboring router, and the OSPF routing is neighborship is done and they are sharing the routes. So we should not change the router ID after the neighborship is up, right? But still, if we change it, then let's see what happens. Once we give this command, what is saying that reload or use clear IP OSPF process command for this to take effect. Means if we do not clear the OSPF process running, then till the time the router ID will be the same. Clear? So let's check the first, what is the router ID right now. You have the given the command, but still what is the router ID? So do show IP protocols. Let's use that command, and you check that still the IP address, router ID is the same what was earlier. We have given this command 1.1.1, but still that has not taken the effect because it was saying to clear IP OSPF process. So let's do the clear IP of OSPF process. Just write the command end, right? And we do command clear IP OSPF process. Enter. It is asking to confirm if you really want to clear. Yes, I want to clear. I'm really happy with that one. Neighborship is going down. It is going from full to down, and very soon it is again coming from full to down to up. Yes, loading to full. Now again it is same revert. Earlier it was full to down, and now from the loading to full, means it's again working now. Perfect. So, but our exercise, let's check the router ID now. Show IP protocols. And yes, new router ID has taken effect. So that's the same thing. So it means the first priority is to the router ID, and the second priority is actually to the loopback interface. You might have seen that it is taking the physical IP address, but actually what is that? The first priority is router ID. We configure first priority is to the manually, means you have given the command to configure it. Second priority is to the loopback IP address. And the third priority is to the physical IP address. So you might have observed that in the previous example, the router ID was the physical IP address, right? Why the loopback was not taken effect? Because there was no loopback IP configured on the router. And then directly we given the manual, and the manual one taken the effect, and the manual router ID has been set right now. Let's see the example of the loopback IP. I'm going to remove this manual router ID right now, right? I'm going to remove that manual one, and let's configure the loopback. So let's go to router OSPF 10. Let me check, go to config T first. Router OSPF 10, and I will give the command no router ID 1.1.1.1. Exit, or we can give the command end. Let's check it has taken the effect or not. If not, then we have to clear the OSPF process. Yes, it has not taken the effect, so we will run the command clear IP OSPF process. And this command clear IP OSPF process is not recommended to give again and again in the live network. Okay, you cannot give this command because once you give this command, that is a traffic affecting, because it will just clear all the routes learning from the OSPF. So it is not recommended. We are just doing for the lab purpose. And let's check the router ID now. And it has not taken the effect, right? It is still the 1.1.1. Why it is happening? Let's not waste the time here. Let me configure the loopback IP on the another one. That was, I will troubleshoot it further. Let me go to the router 2 first. There we don't have the configured the manual router ID, right? So let's just check that first. Show IP protocols. So here we are having the physical IP address. Let's configure one loopback IP address, right? So config T and interface loopback. I'm creating one loopback IP address. Loopback. I think you guys are aware what is loopback IP address, right? Or you not? Let me explain it. So normally what is happening whenever you are having one router like this, right? So in that case, there are multiple interfaces from the router, and then you assign one of the physical IP address to that router, right? So whenever you assign the IP address to the physical, it means that is having the physical IP address. You can just ping that one directly, right? It resides somewhere physically. What about this loopback? Loopback is actually the logical identity, right? So logical identity means that it does not reside in any of the physical port, but still it exists. What is the problem with the physical IP address is like suppose this of your link goes down. In that case, you cannot ping this IP address. What about the logical IP address? That logical IP address does not reside in any of the physical interfaces. Even your that link goes down or another end router is not working, but still that logical IP address is somewhere inside our router, and that is running. That is somewhere inside, and that is running, and that is not related to any physical port. So it means that suppose you have assigned any of the IP, like suppose 10.10.10.10, right? That can be reachable. Suppose you assign any of the IP address here, this link goes down, you cannot reach that IP. But if you assign this 10.10.10.10, and if you have any alternate path to reach that one, you can still ping that IP address. So this IP address, loopback IP address, is normally used for the troubleshooting point of view. For the troubleshooting means you can just check that whether your network reachable or not. So that is the main purpose of the loopback IP address, and normally we assign in all of the routers. So that's what I'm doing here. I'm just giving one loopback IP. So I have created one loopback. I'm just giving the IP address here. So let me give the same thing, IP address 10.10.10.10, and the subnet mask I'm giving 255.255.255.0. Perfect. And no shut command is not required, because if you see the message, the chained status is already up. Once you create it, it automatically goes to the up state. So the most important part, that what is the router ID. So let's just check it. Show IP OSPF. No, show IP protocols. And the router ID is same as it is earlier, because we did not clear the OSPF process yet, right? So let's clear IP OSPF process. Yes, that's perfect. Let's wait to come it up from loading to full. It's done. And now let's check it. Oh, it is still the same. Why? What did you observe here? That even if you restart the OSPF process, the router ID does not change, right? Why it does not change? Because the first, I just told you, the first priority is of the router ID. That's clear. And whenever I assigned it manually, it was giving you a message to restart the process, right? But when did you configure the loopback IP address? Did it ask to restart the process? No, it did not. What happened earlier? There was no loopback IP address and there was a physical IP address. It has taken the physical IP address, and even if you configure the loopback IP address, even then the router ID taken by the physical IP address does not change by the loopback address. But if you configure it manually, then it will ask to restart the process and it will be changed. Right now, you guys might be thinking, then why I am seeing that the loopback is the second priority, right? You're getting confused. Let's see that example like this. Let's do one thing. Just let's restart our router first. I'm going to switch it off, switch off, switch on, and now let's wait for the whole configuration. We will configure everything from the scratch in this router too, right? This time I will change the name of the router to the router 2 so that you can also see it here, because what happens that sometimes you miss that I'm working on the router 1 or router 2, right? So you have to watch at the top here, okay, that it is, oh, it's router 2. So like that you don't have to watch. Let me change the host name this time. Config t host name router or caps router 2, and focus the second thing what I was saying, that the loopback IP address is the first priority. What happened till now? You just observe the physical IP address. Whatever the physical IP address was, that was configured as the router ID. Let's first configure the loopback 0, and I'm going to give the same 10 dot IP address. I just forget the command sometimes. IP address 10 dot 10 dot 10 dot 10, and the subnet mask 255.255.255.0. Put it. What happened? Oh, I forgot one D. Yeah. Perfect. And let me assign the IP to the interface as well. Interface Z0/0. Right. And here IP address in the router 2, it was 10.1.1.1.2, and the subnet mask is 255.255.0. I have to give the command no shut. Let's check first how many IP addresses we have till now. Show IP interface brief. How many IP addresses we are having? We are having the two IP addresses, 10.1.1.2 and 10.10.10.10. Right? So if I run the OSPF now, till now we don't have any IP protocols, show IP protocols, there is nothing, right? It just, if I give the command again, it comes the same, right? We don't have any routing protocol. Let's configure the show IP protocols. Not sure what I'm just doing. Config t router OSPF 10. Silly mistakes. ROUTER OSPF 10, right? Did I advertise the network till now? No, I did not. But I just started the OSPF process, and let's see that have the router ID or not. Do show IP protocols. And yes, we have the router ID, and that has been assigned as 10.10.10, right? So what it does, what it did actually, it took the loopback IP address as the first priority. Right guys? So that's what happens whenever there is a no loopback IP address, then it will go to the physical IP address. So the first priority, if you configure it manually, now I think you understood very well. The first priority, manual configuration of the router ID using the command router ID and something. Second is the loopback, if you have configured any loopback IP address. And if you have configured multiple loopback IP addresses, then it will take the highest IP address. How is that highest? Let me tell you. Suppose you have configured, right now we have configured one IP loopback IP address, that's 10.10.10. If you have also configured loopback 1 as 20.20.20, then what will be preferred? This one. This will be your router ID. The same thing is going to happen with the physical. If you have multiple physical IP addresses, then it will be taken as the highest. So the first one is the top priority. If the first one is not there, then second one will take effect. Highest loopback IP addresses will be assigned as a router ID. If you don't have the loopback IP addresses as well, then our physical IP address highest one will be the take effect if you have the multiple physical IP addresses. Clear, guys? That's quite enough. I have taken too much time on the router ID, but I feel that was really important, and I hope you liked it as well. Right? It's because the more we discuss, the more we learn, and the more problem we face, the more we learn. So this is the way. That's how we learn it, right? Let's go to our slides once again. So this router ID is clear very much, guys. And one more thing I just want to tell you, there is a difference between the neighborship and adjacency. There are two terms, neighborship and adjacency. It is very important. Sometimes it's asked in the interviews, what are the neighbors and what are the adjacent? So they also call it as neighborship and adjacency. You can also say at the two routers, they are neighbor, then what is the difference? And when the two routers are adjacent, then what is the difference? What is the difference between the neighbor routers and the adjacent routers? So neighbor routers are the routers who are just sending the hello messages to each other. That's it. They are the neighbors. They are exchanging the hello. And whenever the two routers, they share the hello, obviously they will share the hello, but they also share more information. They share their database as well with the neighboring router. When they share the database with other routers, they are called as the adjacent routers. Means the two adjacent routers will be having the same database. So it is forming the adjacency with this router, and they are just neighborship with each other. So here they are just sending the hello packets, but here they are also sharing the same database. It's like the two friends sharing all their thoughts with their friends. So they are adjacent, and just two friends or classmate, they just meet to them. They say hi. That's it. They don't know any more about themselves or their self, right? So that is just called neighbors. So that is the terminology I just thought to discuss. And that's we discussed too much detailed, and let me not remind it again, don't waste your time here. So the very important topic, that is our OSPF states, right? So whenever we are having the two routers, router 1 and the router 2, right? So whenever the router 1 is sending hello, right? It is sending the hello, but it is not receiving hello. That is a state of doubts. Means that we have configured the OSPF or R1, but still it might be that OSPF is not configured on the router 2, and that's why it is not the receiving the hello packet. So in that case, whenever it is not receiving any of the hello, then that is a down state. Okay, and this attempt is normally it's not applicable. This is just applicable in the non-broadcast multi-access networks. So in the normal scenarios, it will directly jump from down to init. So once it is sending the hello, what is happening? Let's suppose the router 1 is having the router ID of 1.1.1.1. It will include this one in hello, and it will send it to the router 2, right? What it does, router 2 will send this back to the router 1 hello, and it will tell in the hello that I have information about you, router 1. So it means that when replying this hello, it will include the router ID of the router 1 because it knows about the router 1. So it, for just to inform that router 1 that I know about you, it will mention its router ID in its hello packet. So when this is happening, that is called our init state. It means that the receiver's router ID is included in the received hello packet. Clear, guys? So after that, it has received that one, it goes to the two-way state. So two-way state means that the bidirectional communication has been established. Means the router 1 is sending the router ID of router 2, right? Because like this, the same thing happened as router 2 has told the name of the router 1 or router ID of the router 1. The same thing it will do, that it will tell to the router 2 that I have information about you as well. So the same thing when it is happening both the ways, then that is called a two-way, right? So once the two-way state has been established, they are having the bidirectional communication with each other, router 1 and router 2. It goes to the X start. X start means they are trying to elect DR and BDR. In fact, this DR and BDR is done at the end of this two-way state. And after that, just election is being done and they move to the X start. Means that after in reaching in this X start, the DR and BDR election has been done. You might be wondering then what is this DR and BDR? So DR stands for the designated router and BDR stands for the backup designated router. I will explain this one in the coming session. What are these? Because that's also very important topic, and I just want to dedicate one session for DR and BDR. So what is happening in the X start, that the two routers, they have to share their database with each other. So one of the router has to be master and other should be slave in order to communicate properly, right? Because if you are having a team and if you don't have a manager, then your team does not perform well. They do not do very well. So what will happen in the X start state, they will elect one master and one slave, and normally highest router ID router becomes master and the remaining becomes slave. So this master slave election happen, and after that selection it goes to the exchange state. Exchange means now they share their database. They will send DVD packets or DVD messages in the form of LSA. That is a link state advertisement. It means that in the exchange state, they share their database. Once they share their database, what happens, that it might be the case that it has received some less routes and another router 2 is having the more routes. So when they match with each other, they request the routes and they send the LSR, link state request, right? We, in the beginning of the class, we discussed different type of messages. So this LSR message is being sent on the loading state, and once it will send the LSR to the router, it will send the LSU, that is link state update. Whatever the information was missing on this database, that will be updated by this router, and whatever, if this router is having some less information, then this will send the LSR for that one, link state request, and this router will update to this one, that these are the remaining routes. Once both the routers are having the same database, they are converted to the full state. Full means the two routers will become full state when they are having the same database with each other. So that is the concept of our full. Once the two routers are the full, it means that they are sharing the routes. Whatever the information is having one router, that is updated on the other routers. So that is the finest stage of the OSPF process. So I feel that's it for the day. In the next class, yes, it's done. So in the next class, I will the first focus on the DR and BDR. Okay, guys. So if you face any issue in this session, please first you may write in the comment section. And if you are watching it recently, so you might join our live classes on Saturday. You may ask any doubts, or if you are in the our groups, you can also reach me one-to-one in the groups, Facebook or any other platform, right? That's you can do, and you can ask any of the doubts. So that's okay. See you in the next session discussing this DR and BDR. Till that, bye bye.